Thank you. So there's an increased mobility and therefore a different way of how we use information. And with the increased availability of internet-connected mobile devices, there's a shift on how people even more use information. For example, two friends might be meeting in a cafe to discuss their upcoming vacation. They both get their iPods out, load up Google Maps and start looking around for places to go. And once they have found a few places, they start sharing them with each other. They're going through a process of finding locations they're interested in, discussing them, and then making decisions to include them in their upcoming trip. And how about we now imagine for just a moment that these two people brought an additional iPad and they placed a tablet in the middle of the table as sort of a shared display. And now this additional device can be used by any of the people around the table in addition to their own personal tablet. And this shared tablet also exchanges information with the other devices. And in our work, we're interested in how these multi-device configurations influence the processes of working together and if and how we can support these activities. And we're interested in bringing mobile devices together for cross-device interaction. And this process of creating a shared trip agenda is concerned with sense-making activities on the one side and decision-making activities on the other side. So collaborative sense-making is about analyzing information in a structured way by collecting and organizing those pieces of information to derive insights and eventually arrive at the right result, on the one hand. On the other hand, compared to a structured sense-making task, however, a collaborative decision-making task, there's not always a right or wrong answer. The decisions are influenced by the opinions that people have or the preferences they hold. And in our work, we use trip planning as an exemplary task for collaborative decision-making activity in an iterative process of sense-making. So we wanted to investigate the role of an overview device in multi-device collaboration. And I'm really excited to be here today at CHI and present this work, which was done in collaboration with Joshua Kevin Budiman, Stephen Houben, and Nicolai Marquardt. And I'm Frederik Brudy. So much previous research has explored how large interactive surfaces can support collaborative work. For example, Eisenberg and co-authors have found that using a tabletop display in a sense-making activity led to more closely coupled collaborations, more sharing of information, and more and deeper discussions. And by introducing the mobile handheld devices into a collaborative tabletop system, Seifert and co-authors allowed users to switch between individual work on personal devices and the collaborative work on shared display, which in return led to increased and better group collaboration. And Wallace and co-authors have combined a tabletop display with mobile tablet devices. And in their study, the presence of that tabletop led to improved sense-making performance by enabling groups to prioritize information, make easier comparisons of data, and to build a working understanding. So shared displays support sense and decision-making activities by creating a shared understanding and mutual awareness of what everyone in a group is doing. However, recent studies suggested that an increased size of a shared space does not necessarily lead to improved collaborations, as participants' attention may be diverted towards the screen instead of other collaborators, and that users are hesitant to use multiple devices in parallel. And furthermore, meetings often happen spontaneously, and the tedious setup of tabletop displays or wall displays contradicts the ad hoc nature of meetings, and therefore previous work proposed to use mobile personal devices in collaborative scenarios. So we therefore wanted to investigate if providing collaborators in a multi-device scenario with a shared space in the form of an additional tablet influences their sense-making and decision-making practices. And our contributions are the findings from our study of how those multiple tablets are used in this ad hoc activities. So we studied this through a co-located collaborative trip planning task in an ad hoc bring-your-own-device setting. For this purpose, we implemented Voyager, a very simple multi-device tool for planning a sightseeing tour through a city. And Voyager allows users to combine their personal tablets or their personal devices, such as smartphones and tablets, in order to create a shared itinerary. And each user can suggest and edit the group's shared map on their personal device, while a summary of the trip is either shown on individual devices or on the separate overview device. And here we go. And previous works have proposed to use, as I said, personal devices to collaborate with each other instead of tabletop and wall displays. And we are building this work we are building our work on this notion. And Voyager is therefore a representative of such a system in the wider cross-device domain for using personal devices to collaborate. So, how does Voyager work? On their individual devices, user can search for landmarks or places of interest via Google Maps search interface. And they can then share these locations with each other, and shared locations also appear on the shared overview device, to which everyone around the table has access. And users can annotate their shared locations with a visiting order and a duration to create their shared trip itinerary. So on the individual tablets, this is how the interface looks like. It's a full-screen map, a search bar at the top left. Shared locations appear on all connected devices with their title and a small flag. And locations that have been assigned a visiting order and duration appear as so-called annotated locations. On the shared device, the locations appear connected via an air path to indicate the visiting order. A progress bar at the bottom shows the screen. At the bottom of the screen shows how much of an allocated time limit for the entire trip has been reached already. And then we took Voyager and we studied 3 different conditions. First, with overview, where each participant had their own device, and in addition there was an extra tablet available on the table that showed the overview information. Second, integrated overview, where each participant had a small inset window on the lower left showing the same information that the overview of the first condition did, but on their own individual tablet. And third, no overview, where each participant only had their own tablet device. And so we recruited 40 participants in groups of 4 from our university and via snowball sampling. And when recruiting, we only had 2 requirements to the participants. First, they had to be somewhat familiar with London, having lived there for at least 6 months. And the second requirement was that that the participants in each group had to know each other. And this was directly imposed by our task motivation, because groups of strangers would probably not get together and plan a day trip together. And further, this would allow for a more relaxed communication setting between the participants. And we conducted 4 sessions with the overview device, 3 sessions with integrated overview, and 3 groups participated in our study with no overview. All our sessions were video recorded to analyze the group's collaborative practices. We recorded touch and search input on the personal devices and the shared tablet to quantify the participants' interaction. And we used questionnaires and semi-structured interviews to get further information from the participants. And we coded the video and the other data for the collaborative practices of the groups and participants' interactions with each other, with their devices, and in case of the overview device, with the shared device. I'm not going into more details here, so for more details on how the coding was done and how we developed our analysis in general, please see our paper, which is paper 300 in the proceedings and on the USB sticks. In that paper, we also describe our findings across 3 different themes. First, strategies used to organize the information. Second, how they applied the overview into their workflow. And third, the collaboration styles in the groups. And for time reasons, I will only discuss a few of the findings in themes 2 and 3 now. So when applying the overview, we made 4 observations. First, the overview allowed groups to detect patterns of location that can be easily visited together. Second, the overview created a shared understanding, and groups with the overview, so as a reminder, the one that had a separate tablet in the middle of the table or as a lower inset on the lower left of their own screen, those groups tried out different options for timings and visiting orders, and this led in return to considerations of more options, and I'll go a bit more into detail of what those options are later on. And also groups with that overview, they shared more opinions, and in particular also more people shared their opinions. And this resulted therefore in what we call a more democratic decision-making process. fourth, the overview led to iterations of the itinerary, and this resulted in groups to spot and correct errors they had made, and allowed them to account for additional factors such as lunch breaks and travel times. And in particular interesting was when displaying the overview on a separate device. This led to more closely coupled collaborations and more face-to-face interactions by giving the groups a spatial and a contextual focus point. In particular, we observed 5 different collaboration styles within the groups that range from closely coupled collaborations on the one end, to loosely coupled or no collaborations on the other. The 5 categories that we describe in the paper are active discussions, where there's a face-to-face discussion between group members and limited interactions with the system. Single shared view, where all group members allocate their attention to one single device. Disjoint and shared view, where 2 to 3 members focus their attention on a single device while the others continue their discussions. Disjoint and distributed view, where 1 or 2 group members are focusing on their own device while the others continue their discussions. And lastly, distributed view, where all group members are focusing on their own device and there's minimal to no discussion or interactions with each other. These categories are also part of our video coding scheme, and I described in a bit more detail also in the paper. And I would now want to give a few examples of how the overview device was used as a spatial and contextual focus point to allow group members to transition from those loosely coupled collaborations here at the bottom of the screen to more closely coupled collaboration at the top of this figure here. So we found that the overview device acted as a spatial focus point. In particular, a person's pointing gesture could trigger shared attention. So for example, here in this picture, you see a group with an overview device, and participant 8 here points towards the shared device, which resulted in other members to look up from their own tablets and looking at the overview device. He then started a discussion about where and when they should schedule a lunch break. So they're engaging in single shared view triggered by the pointing of participant A towards that shared device. On the other hand, in this image here, on the right, you see a group without an overview, and participant 29 on the left points at her screen to discuss a location. And another participant briefly looked at the screen, here the one on the right, but quickly shifted her attention back to her own tablet. And the other participants did not notice what participant 29 was doing, as they were focusing on their own screens. And so the group continued to stay in distributed view. And compared to this situation on the left, the participant's 29's gesture on the right was not obvious or not explicit enough for other group members to actually notice it. And in general, we observed that the overview device that led to more shared attention and more closely coupled discussions by giving participants a shared spatial focus point. On the other hand, the overview also acted as a contextual focus point. That means that discussions that started about content on the overview often led to active discussions without groups focusing on any device at all anymore. For example, here in this picture on the left, the group focuses on the overview device, similar triggered by a pointing gesture of one of the participants, as in the previous example with the spatial focus point. And then they used the information on the shared device to synchronize what they were talking about and to find common ground for their discussions. If the information on the device was then not needed anymore, they continued their discussions without paying attention to any of the devices at all. So to come towards a few of the reflection points of what I have just talked about and what we'll be talking in further detail in the paper, previous research around tabletops has shown many benefits for collaborative decision and sense-making activities. However, we increasingly encounter multi-device and multi-user scenarios in ad hoc situations, and we therefore wanted to explore how the role of devices influence groups and collaborations. And we did this through the study of Voyageur. And we described in our discussion, we discussed a bit about space and focus. And groups with the overview device, every member could engage with the shared device equally. And as said before, we observed that the overview device was used as a spatial as well as a contextual focus point. And we observed that groups with the shared device worked in more closely coupled collaborations, leading to more active discussions, and as a result, more people's opinions were heard and the decisions were unanimously. But interestingly, only 2 of the groups that had an actual overview device, they moved that device around, while the other groups treated it almost like a fixed display on the table. In those groups that moved the overview device, we observed more spatial movements as participants were shifting on their chairs or standing up to have a better view. And this spatial movement also seemed to contribute to more closely coupled collaborations. However, whether the more closely coupled discussions were a result of the movement or the movement was a result of the more closely coupled collaboration is something that we can't answer and needs further investigation. So a decision-making task is strongly influenced by people's opinions, and therefore it is one important goal that group members have equal opportunities to share their thoughts and express their opinions. For groups without a separate device, group members were focused on their own screens, and eye contact was less likely to develop, which discouraged potential active discussion and led to comments ignored by the group. Further, in those groups, a leader often kept an eye on the status and updated the group or even stepped in to make decisions on the group's behalf. The overview, on the other hand, allowed groups to build a shared understanding of the process because all members had equal access to the information. So in our study, we have explored a simple collaborative task in a multi-device scenario, and while the study was conducted in the lab and with this very specific focus, we hope that our findings will help researchers for real-world collaborative multi-device settings, and we have explored how the change of a simple device configuration in a group collaboration can lead to different outcomes in different group dynamics. And we're now further exploring how these device-related group dynamics can be effectively leveraged and used to support other collaborative tasks, such as when collaboratively creating artwork or doing curation tasks in everyday situations. And with that, I thank you very much for your attention, and I'm happy to take any questions now.
We have room for a couple of questions. Please state your name and...
Yes. Hi, Frederik. Andres Lucero, Aalto University. This is great work. We did something similar, of course, on mobile devices, so smaller scale. And there what we observed was that sometimes people would some people within certain groups, as they take different roles, they would naturally, some of them, so for example, you had a picture of the girl with the device on her lap, where a person would sort of take the overview as their main device and would just sort of follow the discussion and provide input. Did you find something similar here with tablets?
Mm-hmm. Interesting question. So, as I said before, with the overview device, only 2 of the groups actually picked up the tablet from the table and moved it around, and the others didn't really pick it up. For those that picked it up, they used it in various different scenarios. Some of them, they used it to show it to someone else, sort of to someone sitting next to them and showing it over there. So there were various different dynamics within the group using that overview device. Interestingly, with the integrated overview, we thought that there would be a lot more sharing of, hey, look at my tablet, but we didn't really find that. If anything at all, they were just holding it to someone, but they didn't interact with someone else's tablet. So we also had a bit of an aspect of territoriality in there.
We have room for one more question. While you set up, maybe
hey.
if... Oh, you have, sorry.
Sorry. Nargis Mahyar, UC San Diego. From the picture that you showed from your group, I noticed that there were a group of all female versus all male, and I wonder if you noticed any differences between how they collaborated closely, or did it affect their collaboration at all?
Mm-hmm. So you mean, for example, this here? Yeah, so interesting question about all female and all male. We did not look at that at all because our requirement for the groups to sign up was just that they are friends or that they know each other. So we did not code the data at all about female or male. We had about, I think, 21 women participate and 19 men participate, but we did not look at that data at all.
That would be interesting to explore.
Yeah.
Thank you very much.